Quadratic functions. We know what functions are. We know how to determine if something is a function. The easiest way is by the vertical line test. So we know all parabolas or quadratic functions are either going to open up or down. So both are going to pass the vertical line test. Every vertical line will only cross the graph at one point, so therefore all quadratic equations are functions. Whether they're in standard form, AHK form, they can certainly be written as functions. So we can still find the vertex, axis symmetry, intercepts, and so forth. But we're going to introduce a new term for something we've already been working with or discussing. For instance, for a parabola, we just said it can either open up or down. The way we determine that is A. If A is positive, it opens up. If A is negative, it opens down. And that terminology works just fine for quadratics. But working with functions, we want to come up with some terminology that works for all functions, not just quadratic or not just one or two. So instead of using the term opens up or down, we're going to call it an x-axis reflection. So your basic graph of a quadratic already opens up. So if there is no x-axis reflection, that means that parabola opens up. If there is an x-axis reflection, it means it opens down. And just what the name implies, an x-axis reflection. Take your basic parabola, for instance. Y is equal to x squared. If A is negative, the graph is going to reflect over the x-axis. In other words, basically, if you make a fold along your paper along the x-axis, the part of the graph above the x-axis is going to now reflect below it, which is going to look like this. And that's important, like I said, for other functions other than quadratic. For instance, the function f of x is equal to x cubed. The graph of this basic cubic function looks like this. So the terms opening up or down does not apply to this graph. It doesn't make any sense. So that's where the x-axis reflection comes in. This is the basic graph. In other words, there is no x-axis reflection. For f of x equal to negative x cubed, where a is negative, in other words, where there is an x-axis reflection, the part of the graph below the x-axis is going to be reflected above it. And the part of the graph above the x-axis is going to be reflected below it. So just a terminology that works for all functions, not just one or two, like opening up or down. So we know, going back to parabolas, if it opens up, or in other words, if there is no x-axis reflection, that vertex is going to be the minimum point on the graph. If it opens down, or if there is an x-axis reflection, that vertex is going to be the maximum point on the graph. So if that's what you're asked to find, a maximum minimum point, it's just another way of asking you to find the vertex. However, if you're asked to find the maximum or minimum value of the function, that's going to be the y-coordinate of the vertex. Since the y-coordinate is the value that measures the height, how tall the point is, that's going to be the maximum or minimum value. So read the directions, read each problem carefully. If it's asking for maximum or minimum value, it's asking for the y-coordinate.